to start this exciting panel today. So our panel is a side event on AI for extreme weather in a changing climate. So I have a very distinguished panel here. We'll first introduce them quickly. We have Grazina Piesiewicz, Head of Unit of the Open Science and Digital Modeling, DG Connect, in the Directorate General for European Commission. Then we have Rochelle Schneider, Destination Earth AI Application Lead at the European Space Agency. Pete Cluton-Brook, co-founder of the Center for AI and Climate, and also CEO of Radiance International Consultants at GPAI and GPAI Expert. We have Ime Ebert-Uphoff, professor at CSU, the Colorado State University. She's also machine learning lead at the Cooperative Institute for Research in the Atmosphere and CSU lead for the NSF AI Institute for Research on Trustworthy AI in Weather, Climate, and Coastal Oceanography. And finally, Florian Pappenberger, Director of Forecast at ECMWF, in charge of AI activities at ECMWF and GPAI Expert. And I'm Florence Rabier, I'm Director General of ECMWF, the European Center for Medium Range Weather Forecast. So we have quite a few panel members and an exciting program in front of us. First, maybe I will ask you a panel-wide question to whoever wants to respond to can. Why do you think now is the right time for AI in weather forecasting and climate? Who would like to answer this one? Yes, Ime?
I think there are kind of three reasons. Number one, we have a lot of data. We have about 50 years of satellite data now, and we have lots of model data. So we actually have something to train on. Number two, the tools are becoming mature. So, things like ForecastNet that NVIDIA just developed really shows that AI algorithms can start to compete with some of the weather prediction models and climate models. And number three, I think the community is starting to be ready. 10 years ago, people were just asking, why would we use machine learning for that? No, we need physics. And of course, we do need physics. I'm the first one to say we need physics. But I think the community is ready to at least give it a try and be open-minded about using AI tools with some caution.
Okay, thank you. Anyone wants to pick up on this? Yes, Rochelle?
Yeah, I could actually add as well that AI is ready to help us beyond just the algorithm of forecasting system, but also in the hardware perspective. So helping us is speeding up the high performance computing and speeding up small processes that before was not possible. So it's helping us to save energy, save time of people, and then help us to allocate the same processors for new users for that was not possible before.
Okay. Anyone else, or do I go to general question? Maybe Pete had started and Florian.
And I think the other thing to say is there's also a demand for higher resolution, higher granularity forecasts coming in now, and especially as we start to use, for example, more renewable energy in our energy systems. As a result of that, we need really high forecasting, really high resolution forecasts for things like solar and wind, which are going to be becoming more prominent on our electricity grids. And in order to balance those grids, we need really high resolution forecasts in order to do that. And that's somewhere again where these kind of technologies can be applied to good use.
Okay, so on the demand side, yes. Florian? No.
No, I was about to say the same thing. Thank you very much.
Okay. Okay, so let's go to maybe a question for the panelists now, a bit more specific. So Grazina, you're working at the European Commission, so can you explain a bit what AI-related initiatives the EU is leading? And in particular, if you could say a few words about Destination Earth that some of us have heard about?
Yes, of course. Thank you, Florence. The EU is leading really a comprehensive package sorry, of AI initiatives since really 2018, more or less, when it first presented a first version of this comprehensive package, which has since been reviewed and as lately as 2021. And this, it is a comprehensive package because it contains many different elements, a critical component of which is an effort to maximize resources and coordinate investments. And in particular, through its Horizon Europe, which is the research funding program, and Digital Europe, which is the implementation funding programs, the Commission, for example, has proposed to invest 1 billion euros per year in AI. And this money is supposed to leverage additional investments from the private sector and the member states, in fact, in order to reach an annual investment volume of about 20 billion euros over the course of the decade. And this money is supposed to support, for example, the new public-private partnership in artificial intelligence, data and robotics. It is supposed to strengthen the AI research excellence centers, which have been put in place, setting up AI testing and experimentation facilities, providing support for equity financing for innovative AI startups through another EU program, EU funding program that is managed by the European Investment Bank, which is called InvestEU, and support, for example, public procurement of AI through an entirely new program, Adopt AI. So besides investments, in fact, another element of that package are initiatives in adjacent digital areas, which also benefit AI. So I'm thinking here about access to high quality data, which is an essential factor, as some of you mentioned, in building high performance, robust AI systems. And in this case, initiatives such as the EU Cybersecurity Strategy, the Digital Services Act, the Digital Markets Act, the Data Governance Act, what have you, they provide the right infrastructure for building such systems. And all this is really to promote the development of AI throughout Europe. Now, as recently as April 2021, also the Commission has proposed a regulatory package for AI because, in fact, in Europe, there is a strong, let's say, commitment to a trustworthy AI so that we enhance let's say, readability of the population and of policymakers to adopt AI as well. So, but those were AI initiatives in general, and I really just skimmed over them. But you asked me specifically about Destination Earth, and this is the program that I lead with my team. And this is a flagship initiative of the EU to develop a highly accurate digital model of the Earth, a digital twin of the Earth. And basically in a time of accelerating changes, such as those triggered by global warming in particular, but also the recent pandemic, it really is becoming increasingly important for decision makers to react, to be able to react rapidly and on solid scientific grounds. And Destination Earth really showcases the important role that digital technologies and digital infrastructures can play for the green ambitions, not only for the Union, but also globally. So with Destination Earth, with this initiative, we will leverage the full spectrum of available digital technologies and infrastructures, from cloud to AI that we are talking about here, the new network of Europe's high-performance computers, and vast amounts of data from very different sources, the main of which is Earth observation sources, but not only, and that is one distinguishing factor of Destination Earth. So in mid-2024, we should have the very first version of this next generation prediction and decision support system. And the system will first integrate two digital twins, one on extreme weather events and one on climate change adaptation, with which we will be able to not only assess the past and monitor the present, but really predict events and model the most advantageous scenarios on how to adapt to climate change and mitigate future possible disasters. So really testing and playing with the what-if scenarios. And then in subsequent phases, the models and data, which are already included in the open platform, will continuously be enhanced and improved. And new digital twins will be added, for example, the digital twin of the ocean, biodiversity, hydrology, just to name a few. And of course, the initiative, I cannot not mention this. The initiative is, of course, implemented by 3 distinguished institutions, the ECMWF, which you represent, the European Space Agency, and EUMETSAT. And it is funded from the Digital Europe program, which is the implementation program, with initial funding of 150 million for the first phase, and then still to confirm 120 million euros for the next phase, each phase spanning more or less 30 months, with additional significant investments from the Research Horizon Europe program. So in essence, just to maybe finish and make a link with artificial intelligence, with Destination Earth, and also through synergies with other programs in place, we in fact will be filling a void, because at present a joint program to develop such an advanced system through a huge digital technology push and European infrastructures investments funneling its outcomes effectively into well-established service infrastructures really does not exist. And that, in fact, for this to be able to do that, Destination Earth requires the full convergence of Earth system simulation and socioeconomic impacts, science, the Earth observation, and the breadth of really future digital technologies such as AI, machine learning in particular. And those will play an important role in Destination Earth, as precisely artificial intelligence methods allow exploiting the full potential of simulations and observations at extreme scales across the very different components and data streams that compose the creation of a digital twin. And this AI will allow us, its vital role, in fact, consists in the fact that it will allow us to embrace new data sources, improve and manage existing complex forecast models, and allow new kinds of applications to assist decision makers and ultimately all the other users that we want to open up to in the last stages of this initiative. Thank you.
Okay, thank you very much, Grazina. Now, Rochelle, you're involved in this initiative. So can you tell us from the ESA side, can you tell us, explain a bit what are these digital twins and how should digital twins interact with AI? And also if you can touch a bit on how Earth observation data can empower machine learning. Over to you.
Thank you. Yeah, as Grazina just explained, in short, digital twin is a digital representation of a product, a process, or a system. And when we talked about a digital twin of the Earth, in this case, we enter in an information system that combines physical models and Earth observation, so data measured from on Earth. And Earth is a complex ecosystem, and then be able to digitally represent it is amazing for us, because then we can actually see the planet's reaction for different climate scenarios, and we can play with it and see what is going to happen if we increase the temperature in multiple degrees, or if we change some decisions in the policy implementation of air pollution, for example. We can actually mimic this through the digital representation. And this is great because then we can see before it actually happens. So it's a great opportunity to do that. And AI interacts with digital twin in multiple ways in the building process and of the digital twin, and also after that in the making this operational. So as it was mentioned, the digital twin, the Destination Earth is a supply chain, let's say, of collecting data, simulating the data, and later on making this available for the population in a service platform format. So AI is helping in this whole chain, let's say, of the process. And this is quite timely because we just delivered a machine learning workshop, ECMWF and ESA together, trying to answer some questions about how AI can help even more on that topic. And in terms of these, we discussed quite a lot of topics. Of course, I'm not going to cover everything that was discussed, but just highlighted some interesting information of AI interacting with these Earth system models. So this, in this case, we can name it here as a digital representation of the Earth. And we talked about emulating parts of these digital representations and the full representation of the current Earth system models. And we do that because there are a lot of specific variables that are not yet observed through the satellite, for example, or processes that are so complex and non-linear that have to have help of AI algorithms on that. But as I mentioned before, the use of AI in terms of using in a more strategic way the high performance compute infrastructure will help us a lot to save energy, and this is crucial. And in terms of the Earth observation, and this is a quite interesting way to ask, because usually we ask how AI can help Earth observation, and in this case is the other way around. So how Earth observation can help machine learning. And definitely, as we discussed before, we have data. And Earth observation, and I named here as a Earth observation satellites, they have a lot of data collected. And this is crucial for showing the power of machine learning structures to help us not only in the, let's say, satellite remote sensing domain, but helping us to show the value for other applications.
Okay, thank you very much, Rochelle. Now over to you, Pete. How can we best bring together industry, research, and governmental organizations to work on these problems?
On this particular problem, on the digital twin, or in general?
In general, about how to bring together for AI in weather and climate in particular.
Well, I think it's a really good question. I think I guess my answer would be twofold. One is I think I'm usually a bit of a skeptic of bringing people together for no particular reason. I think there's a real power to having a very specific problem that you're bringing people together around. Otherwise, you can end up with a bit of a talking shop which leads nowhere. But I think what's needed is to really define what the core challenges are that we're trying to solve with these technologies and where they could be useful, and whether it's really defining how you get to really high resolution solar forecasts to enable more solar to come onto the grid, or whether it's there's a whole range of potential use cases and potential opportunities here, but you really need to define those first, and then you need people in industry to understand exactly what challenges they're facing in the short term, but also the long term, and that uncovers some of the research potential opportunities where we need the academic community to really be coming together and thinking about, okay, how do we address these sort of long-term blue sky and sort of applied research areas. And then it's just about getting the right people in the room and making it really, really focused on that problem. And yes, that can involve a cross-section of policymakers and industry and researchers, but it really needs to be defined very closely around what that problem is before you start to think about coordinating who you end up working with.
Okay, and what do you think the challenges and the opportunities are in bringing different data modalities together?
I think this is a huge opportunity, and I think it's one that's definitely a bit of a challenge at the moment. I think we're seeing a lot of applications which tend to focus at the moment on a single data modality. So you'll have examples and applications where people are using satellite imagery for their particular work, or you'll have examples where people are using time series data for their application. I think what's happening more and more is you're seeing people wanting to try to use a range of different data modalities, but finding it a little bit harder than it should be at the moment. And linking these different data modalities is going to be really important, and making it really easy and making sure there are good standards involved that people can easily follow, so that all their time series data is in the same format and it can be connected easily to their satellite data, or something like that. All of that needs to be really carefully thought out and with a range of use cases in mind. Because I think if you're looking at complex problems, whether it's with a digital twin of the Earth or sort of a range of other problems, you're going to need to be not just connecting two different data types together, you're going to need to be bringing together as much data as possible from a range of different modalities. And that's where it gets complicated, but also you get more and more opportunities.
Okay, thank you very much. Ima, now over to you. What do you think the challenges are in using AI in a changing climate? And do you think that should ethical AI come into the equation for that problem?
Thank you for the question. So first of all, the obvious, if you have a changing climate and you're training on the current data, and then you're trying to run it in the future climate, your AI model may have to work on scenarios that it hasn't seen before. And we all know that AI isn't always so great at extrapolating. So one of the key research areas is called climate and machine learning, or climate and AI. And you can find a lot of research on that topic already. So if you look at the keywords climate and machine learning, physics-informed machine learning, and all distributed machine learning, these are all frameworks that try to make these AI frameworks work in a future climate. A second challenge, whenever you deal with weather and climate, quite often you deal with rare events. So if you're thinking of tropical storms, you have less than 100 per year, and you have about 50 years of data. So we're talking about 5,000 data samples. So although we think of big data and having terabytes and terabytes of data, your sample size of the events you're looking at might actually be pretty small. So that's another challenge. And then in terms of bringing in ethics, you know, we wrote a paper recently with just lots of examples to raise awareness in the weather and climate world about the dangers of AI that we have to be careful about. So one of the things is everybody thinks data is objective. It comes from sensors. Well, it comes from sensors, but it doesn't make it objective. Because first of all, our sensor networks are not equally distributed. Part of that is just reasons of geography. You can't have radar in the mountains, and some of it is economic. You know, your low income areas or developing countries are not going to have air quality sensors everywhere. And so if your data is unequal, of course, what your machine learning algorithm learns is unequal. There are lots of other limitations in sensors. There are biases. There's a lot of human reported data. If you look at hail data in the US, you think there's only hail in the cities and along highways because that's where it's reported. And so if your machine learning tool learns this, it's going to learn that there's no hail when there's no highway, right? So we have to figure out how to deal with how to find these biases, all kinds of biases, and how to deal with them in machine learning. So that's a key one. Another thing is that people think that the AI algorithms are they're objective. Well, there's so many little model choices that influence your results. For example, if you're modeling, say, temperature across cities, if you want to find out heat islands, you have to make sure that your resolution is high enough that you can actually get those, because otherwise you will totally overlook those. So there are like tons and tons of little choices that the modeler has to make sure that the model actually serves the purpose and doesn't overlook certain populations. And then lastly, I will just say in terms of workforce and society, if all the rich countries come in and say, oh, we know how to do these global models and then just do everything, the developing countries may not get a word on how things are done, what the solutions are. They have a hard time catching up with their workforce development if we just take things away from them. And the last one I will just say, the increase of CO2 emissions from all that computing is something that people are really concerned about by now too. So the whole idea of green AI, how can we reduce the computational effort there? And with that, I will turn over to the next person.
Okay, so Florian, your turn then. What do you think are the most exciting applications for AI in weather forecast and related products, in operational weather forecasting?
Thanks, Flo. I'm sort of going to bounce off what Emil said a bit. I think in a way, the applications are, or the use of AI is through the entire value chain from weather forecasting. So that's from indigesting the observations, which Rochelle mentioned, to the physical model, which was sort of come up a bit earlier, to the outputs, which was mentioned by Peter. So I think it's everywhere a little bit and nowhere completely, because there will always be other methods in between. I think the mistake we never should make is that a single method will replace everything. It won't. It will replace parts of the system with all the problems Emil just mentioned, particularly for extreme weather forecasts, where it's actually going to be quite difficult to use AI purely without any physics. I would actually argue impossible without any physics. You always need to use some physics in there. Which then also makes it, of course, quite complicated to operationally implement, because if you want to have an AI algorithm in an operational modeling chain, the last 10%, so you did 90% of the research, and then you need to push it into this application, into this reliable system, which always works, doesn't fail, produces good results on time, constantly, is quite complicated, because you need to have so many different knobs, which Imi already mentioned, which you need to experts for to fix in case they're fading. So on the one hand, you've got humongous opportunity. On the other hand, you have a quite big challenge of actually making this entire thing work reliably every day when data fail, when systems fail, when computers go down, when the GPU corrupts, when the memory corrupts, and all these different types of things which you need to sort of get ready and make applicable. If you then do all that, you will have massively wonderful solar products. You will have a digital twin of the Earth which looks beautiful, pretty, and performs to a high standard at the same time. But it is a hard work, and one shouldn't forget those last 10%, which will be taking a lot of energy.
Okay,
I
and
kept
now,
it short.
yeah, fine. We just have 4 minutes to conclude, and so I have just one general question for you to see the future. How do you envisage the future? So my last question to some of you who want to answer is, where do you see machine learning being used for weather forecasting and climate in, say, 5 years? Where do you think we will be in the use of AI for these applications in 5 years? Anyone wants to bet in the future? Yes? Rochelle?
We'll make very short. It's just following up what Florian just said, is the message from, at least from the user community that use AI for Earth observation and Earth system models, that we are working hand to hand with AI. So the idea in the next 5 years is not completely replace the current state, what is already working and working well, but just adding as an addition, a helper in the areas that we are not working so well, and or you might speed up some components. So not fully replace, but just some parts of this work.
Anyone want to bet? Yes, Gazine?
Well, perhaps a little naive bet from the policymakers' point of view, but building on the very optimistic statement of Rachel, I have no doubt that we will be using AI and machine learning in Destination Earth, whether to its fullest extent already with the first version of Destination Earth, that it remains to be seen, but definitely as 5 years is beyond that phase and actually bringing us quite a bit closer to the end of phase 2, I have absolutely no doubt that we will be using AI to deliver what we want to deliver with Destination Earth, and perhaps more. So perhaps a bit naive, but we have to. Well, not naive, maybe optimistic, but we remain optimistic as we must as policymakers. Thank you.
Absolutely. Ima? Sorry, Ima first. Yeah.
Okay. So I think we will really improve global weather models and climate models, especially by replacing just the slowest components like radiative transfer equations with AI, but leaving the rest of it as it is, all physics-based. And I think with that, we will have much higher resolution and much faster models soon. So better uncertainties, higher resolution, better local forecasts. And I think we also will make a lot of progress then in predicting like extreme events, whether that's better tracking of forecasting of rapid intensification of tropical cyclones or wildfires, which is a big topic in the US right now. I think we make a lot of progress there. And then finally, emergency management, route planning, like how should you best get out of the area and things like that.
Okay, thank you, Pete.
And 3 quick points for me. I think one is, I think there's a big opportunity to get much higher locationally specific forecasts. So for things like, as I talked about, forecasting solar and wind, that needs to be highly locational specific. So getting those really high resolution, I think, will be really interesting. But I agree with what Florian said earlier, that I think eventually, AI will filter into all areas of the weather forecasting process. Maybe not completely, but it will come. And I think what's interesting is, over the next 5 years, AI itself will develop hugely, and we're seeing breakthroughs on a regular basis now in terms of the fundamental technology. And I think that will provide some opportunities that perhaps we don't even see at the moment. So yeah, it's an exciting time to be working on it.
Thank you. And the final word, Florian?
I can just only agree to what everything was said. I have to admit, I also find it quite interesting to say what's next, what's behind, what's beyond AI, what will be the next step beyond AI. It may be called AI, it may be called something else, but I think that's the exciting bit, which I think we also should see emerging in 5 years. That's the vision, I think, which goes beyond that.
So more implementation of AI throughout the whole chain, and maybe something else coming, and new great progress in science and technology. Okay, I think it's time to close this panel. Thank you very much, all of you. And the future is bright. The future is AI and something else. Okay, thank you all, and have a great day. Bye.
Thank you. Bye.
Thank you.